So in this first section we're going to be looking at the standard integrals. These are the integrals that are our bread and butter in Extension 2, and they're all on your reference sheet. You've seen most of them in Advanced and maybe a couple in Extension 1. Now I say they're on the reference sheet and you can see them on the screen now, but that doesn't mean that you should rely on the reference sheet. There are definitely some of them that you should know pretty intimately. My recommendation would be to know the inverse tangent and the logarithm. So the integral of f prime of x over f of x dx. Those two integrals crop up all the time. Your inverse trig functions overall will crop up all the time. So they're worthy of knowing. Now Extension 2 is going to be all about you getting integrals that don't look like they're on that reference sheet. And your job is going to be to reach into your tool bag and find an appropriate tool that will allow you to modify that integral so that it does look like something on the reference sheet. That's basically 99% of integral questions in Extension 2. What makes them more difficult than Extension 1, as well as actually being often more difficult than Extension 1, is that you will not be given, or you won't always be given, any direction. So in Extension 1, you'll be told, here is a substitution to solve this integral. Here, we won't tell you it's a substitution, we won't tell you whether you need to use partial fractions, we won't tell you whether you need to use integration by parts. I mean, we might be nice, but we probably won't tell you, and you need to, as I say, reach into that toolbox and pull out an appropriate tool to solve the problem. And in your mind, you should be thinking, if they do tell me it's integration by parts, or a substitution, that means that the integral itself is probably going to be more difficult than if they just gave me one and I had to find the appropriate tool. So as a primer, let's go through a simple example, kind of an Extension 1 example, to get the brain moving before we move into the next section, which is on algebraic manipulation. So in this example, we're integrating dx over 3 plus 4x squared between 0 and a half. Now our first line of attack often is to have a quick look at the reference sheet. As I said, eventually, hopefully, you'll have enough practice that you won't have to look at it all that often. But let's look at it now and see, does this look almost like one of the reference sheet integrals? Because that's often our first line of attack. So if I jump on now and have a look at my reference sheet, you can see, hopefully, that it looks very close to an inverse tangent. But to have an inverse tangent, on the denominator there, I need a squared plus x squared. And at the moment I've got a 4x squared, so I need to deal with that. Now the easiest thing to do would be to multiply top and bottom by a quarter. And since on the numerator now I've just got a constant, a quarter, I can pull that out the front of the integral, and that denominator simplifies, I say simplifies, into the right form, a squared plus x squared. And therefore we can just read off the solution from the reference sheet because it's now a standard integral. That gives you a nice primer now for the kind of things that we're going to do over and over and over again in this topic. Manipulate somehow an integral so it looks like one of the standard integrals on the reference sheet, and then we can just read off the solution.